This is lesson 8.5, which is polar form of complex numbers. Our essential question is, how can you use trigonometry to represent and multiply complex numbers? So this first slide talks about, example 1 talks about how to convert back and forth between a complex number in rectangular form and polar form. So you can see rectangular form is writing it as a plus bi, and polar form it says z equals r cis theta. Well, this comes from r times cosine of theta plus I sine of theta. So that CIS is just a shorthand way of saying the polar form. So if we're converting from rectangular to polar, here's our little formulas right here. We're going to find the hypotenuse of that triangle. So we're going to take the square root of a squared plus b squared. And then to find the angle, we're going to take the inverse tangent of b over a. To go the opposite way, to convert to rectangular, we're going to do r cosine of theta and r sine of theta. So our first example is how to convert back and forth between polar form and rectangular form. So the first one, we're turning this equation right here into rectangular form. So I'm going to take 5 times the cosine of 3 pi over 4 to find my x coordinate, and to find my y coordinate, I am going to take 5 times the sine of 3 pi over 4. So we know the coordinate point 3 pi over 4 is at negative square root of 2 over 2, positive square root of 2 over 2. So that's going to make my rectangular coordinate negative 5 square root of 2 over 2, and then positive 5 square root of 2 over 2. If we were writing that as a plus bi, we would just write negative 5 square root of 2 over 2 plus 5 square root of 2 over 2i. So that's how we write that in rectangular form. The second one is how to write from from rectangular form to polar form. So here is our point value that we're switching to polar form. So we need to find our r and our theta. So to find r, we're going to take the square root of negative 7 squared plus negative 4 squared, which gives me the square root of 65. Sometimes we like to leave it as a square root and simplify it, and sometimes we want to put it as a decimal. So in this case, we are going to write it as a decimal. So the square root of 65 is approximately 8.1. Next, I want to find my angle. So I know that negative negative means I'm in the third quadrant. So I have to keep that in mind when I'm finding my angle, but I'm going to take the inverse tangent of negative 4 over negative 7. And when I do that, I get the angle 29.7 degrees. Now 29.7 degrees is in the first quadrant. I want it to be in the third quadrant because I want the x and the y to both be negative. So I know I'm going to need to add 180 to put it into that third quadrant. So that gives me 209.7. So my polar form would be 8.1 cis 209.7. Okay, our next example 4, is to multiply complex numbers. So in order to multiply complex numbers, we're going to use this formula up here. We need to put these both into polar form. So starting with Z1, we're going to find the r by taking the square root of negative 1 squared plus the square root of 3 squared. And that's going to give me the square root of 4, which is just 2. And then to find theta, we're going to take the inverse tangent of square root of 3 over negative 1. Now, this is on the unit circle, so I don't need to use my calculator on this one. I can actually use the unit circle, and I'm going to put a denominator of 2 for both of these, because then I can actually find the y coordinate that's square root of 3 over 2 and the x coordinate that's negative 1/2. So I'm in the second quadrant, and that would give me a angle of 2 pi over 3. So there's my first point, and then my second point, I'm finding the r by taking the square root of 5 square root of 3 over 2 squared plus negative 5/2 squared, and we're going to get 5. And then again, inverse tangent of negative 5 over 2 over 5 square root of 3 over 2. So when I look at this, I see the 5. I see that 5 that is the scalar factor, and I also see the points on my unit circle. So I can see that this is my y and this is my x, and I can see that the y would be negative 1/2 and the x would be square root of 3 over 2, and we're just multiplying both of those values by a scalar of 5. So that tells me I'm in the fourth quadrant, and if I have an x that's square root of 3 over 2 and a y that's 1/2, that tells me I'm at 11 pi over 6. Okay, so now we're going to multiply these. So we're going to use this formula right here. So we have our r, and we have our s, and we have our two angles. So we're taking the 2 times the 5 gives us 10. Oops. And then to find our angle, we're taking 2 pi over 3 plus 11 pi over 6. So 2 pi over 3 plus 11 pi over 6 would give us 5 pi over 2. So there is our new point that we have multiplied together. Okay, example 5. We can use the power formula to raise a polar form into a complex number in polar form to a specific power. So again, we have to be in polar form. So this gives us our value in rectangular form, so we need to convert it, is always our first step. So to find r, we're going to take the square root of 4 squared plus negative 4 squared. And so that is 16 plus 16, 32. So if we take the square root of 32, we can simplify that to 4 square root of 2. Okay, and then to find our theta, our angle, we're taking the inverse tangent of negative 4 over 4. So again, that puts me in the fourth quadrant. And I know that taking the inverse tangent of negative 1, it means I'm going to be at one of my 45-degree angles or my pi over 4 angles. So that's going to put me at 7 pi over 4. So we can apply that formula. We can say z to the fourth power is going to be 4 square root of 2 to the fourth power times cis of 4 times 7 pi over 4. So if I take 4 square root of 2 to the fourth power, I get 1024. And if I simplify my angle here, I can cancel the 4's and I end up with 7 pi. So that would be my final answer.